Hello everyone, my name is Bora Ulaş Bakanda from Mechatronics Engineering and I'm leader of group number 4. My group members are Doğan Berkay Sözer and Zeynep Dedet Ulaş from Computer Engineering and Mahmut Furkan Bakal from Software Engineering. We're going to be doing our presentation on our data set selection for this course. Next slide, please. The data set that we chose is a data set for credit card fraud detection. This is a large data set of transactions taken over a period of time containing information such as the time of the transaction, the amount of the transaction, the pattern of previous transactions, and whether the transaction was fraudulent based on subsequent investigation. This data was released by European credit card companies in 2013. Obviously, criminals can sometimes obtain credit cards illegally and make transactions illegally. Credit card companies and banks want to identify these fraudulent transactions as soon as they happen to prevent theft and credit card fraud. The reason we chose this data set for our project was that credit card fraud detection has a real-life practical use case for preventing the crime of credit card theft, especially for banks who want to utilize algorithms such as machine learning to make detection more reliable and more efficient. Now Zeynep is going to continue with details on the machine learning task.
Our machine learning tasks are supervised learning and classification. It's supervised because our data set is labeled, and it's classification because there are two labels, two classes, so it's binary class classification. Now Furkan's going to continue.
Hello everyone, I am Furkan. Today I am presenting the summary of data which is needed to detect credit card fraud. And this dataset contains approximately 285 key samples and two numeric features. And we have a target which is a categorical outcome with two classes that making it ideal for binary classification tests. And one of the most important aspects of this dataset is that there is no missing data. This is critical because missing data can negatively impact on the accuracy and effectiveness of the machine learning algorithms. Please next slide, okay. And as you can see, that's our data table from Orange Tree. And the dataset consists of 31 columns. After me, my friend Berkay will explain the contents of these columns in detail on Kaggle. Please next slides, okay. And in this table, there are some feature statistics of the our datasets. It's occur median, mode, mean, which are the statistical measures used to describe the central tendency of a dataset. And also we have some other terms, distribution, minimum and maximum values, and the missing data. Now Berkay will continue now.
Thank you, Furkan. Now I will show the dataset of our project, and I hope you guys are seeing the Kaggle page. Right, now I'm going to start. And in this dataset, as Furkan mentioned, we have 31 columns, and the first of all, and the most important ones, one of them is the timetable. And in this column, we are going to look the number of the seconds between the first transaction and the last transaction between these elapsed times. And these columns goes to V1 to V28, and these are the transactions that the European people made in 2014, and these are according to the euros values. And these amount transaction column is telling us the people that made the transaction in euros. As you can see, there's some numbers between 0 to up goes to I don't know where. There's 285k variables, as Furkan mentioned. And lastly, we have the class variable that is 1 for fraudulent and 0 for the non-fraudulent detections. And also I want to mention that these variables are PCA transformed variables because of the fraudulent people protection legal laws. The banks are giving the real numbers, but they are changing numbers according to PCA. And because of that law, these are the not real numbers, and these are the PCA transformed numbers. And I want to show you that there is one table. So these are the products. And as you can see here, there is a lot of differences between each column. And as you can see, -2, 3, 6, and it goes like that, -7, example, -10. -10 means this is less than the average, and -9. Also, if we see the data of the non-fraudulent transactions, we can say that these are more accurate and more balanced around 0. As you can see, I will go to left. These are usually -1 and 0 between. And thank you. If is there any question, I would like to answer them.
Is that all of your presentation?
Yeah, it's all of our presentation.
So you didn't mention about the number of the target values. I mean that the fraudulent or not. How many of them is fraudulent? How many of
Ah, yeah, I am so sorry. I'm so sorry. We have it's in here. We have 284,807 transactions, and we have just 492 fraud detections
so
in
do you
these them.
believe that with this imbalanced data set, can you do a prediction, classification on that?
We hope so, because these are because in this data set, these fraud detections are really goes to high values, because we are usually making some decisions between 0 and -1 to -2 to +2. But if we have see the fraudulent in these transactions, we are looking like -10 to +10. We can detect in
But there
these
is something
values.
wrong here because it's written here. The data set is highly unbalanced. It's written there, right?
Yeah, yeah.
So you have to take a lot of measures. If you split the data into train, validation, and test data, I believe this 0.1% is not enough to train your machine learning model, first of all. The second is that your features are not features. These are PCA results, right? Principal component values, these are.
Yeah.
And you cannot depend on these values because they are just some mathematical calculations. And you cannot then comment on the results. You wouldn't say that the feature, for example, credit card company, or the feature of that the last purchase done date. You don't have such features. So I think this data set is not good for you. How can you implement the data augmentation? How can you talk about the missing data? There is no missing data because it is hidden from you. PCA just creates some principal components, and these values are these. And we know that we will learn in the class, PCA is just one method of dimension reduction methods. So you cannot depend on this for a project. We work on with the features, then maybe we can use the PCA for just visualization or just for adding new values. But just only with PCA, you cannot be successful. It is known. Most of the time it's like that. So I don't suggest you to continue with that data set because there are no real features.
Okay,
Sure.
then we
Yeah, so
can
if it's
present
possible, we can present the second data set. Possible?
Please, let's do it. Please.
Okay.
then I will stop the sharing and Furkan will continue.
Okay, let's
I
go
think
to
we can
this. Yeah, go to this. Let's start with the slide for the second data set. Okay, so to start, our second data set is made for robot navigation. This is a data set of sensor data from 24 ultrasonic sensors around the robot in each direction. And it's used to determine which detection a wall-following robot, or a robot that follows the perimeter of a room or a space, which direction it should turn to navigate and avoid obstacles. Using a machine learning algorithm for this task would allow mechatronics engineers and programmers to avoid having to individually program a robot for every single room or every single space, or rely on possibly noisy algorithms such as image processing. Zeynep will once again continue with details on the machine learning task.
As our previous data set, our machine learning tasks are supervised learning and classification, but this time it's multi-class classification as there are 4 classes. One is move forward, the other is slight right turn, the other is sharp right turn, and the last one is slight left turn. Now Berkay is going to continue.
Hello again. Now I'm going to go to with the quick summary of the data. In this dataset, we have 5.4K samples for the turning positions, and we have 25 numeric features, and also our numeric features target is the classes 1, 2, 3, and 4, and also we have no missing data. For these columns, Furkan will go to in detail, but I can say that these are the turning values. And again, these are the mean, mode, and median that for continuing.
So now I want to see our dataset on the Kaggle. Can you see? Yes.
Yes.
In this project, we have a robot and it has a 24 ultrasound sensors around this robot arranged circularly. And these all ultrasound sensors has a reference angle. That means all sensors are responsible for one area to see, to realize the walls. The mission is without collision in a room, make some movement. And in our datasets, these columns are for our sensor values, the 24 sensor values. And finally, we have our classes, final classes. We have 4 classes. These numeric numbers have some meanings. For example, 1 is for move forward, and 2 is for slight right turn, 3 is for sharp right turn, and finally 4 is for slight left turn. And this data set is more balanced of the previous data sets. We have yes, we have, for example, 2000 samples from the class 1 and 2000 again sample from the class 2, and nearly 200 from the class 3, and finally 800 for the class 4. And that's all. Thanks for listening.
Is that all for the presentation?
Yes.
Yes.
Okay. So first of all, I would like to remind you that both of the presentations, to be honest, I expect you better presentations. Just showing the Kaggle web page is not enough. It shows that you are not so well prepared for presentation, because we are here to listen you, and you need to understand the data set, explain the features, show us the relationship between the feature and the target value. You didn't mention what's the relation with the features and the target value. You haven't used anything that we have seen in the class. You haven't seen any regression values the relation between these. You didn't mention about the distribution of the values with respect to target, turn right, turn left, whatever, right? So I hope that you need to show us these distributions in some diagrams, right? And it shows us, or it indicates that you didn't prepare yourself very well for the presentation. Showing on the Kaggle page is not enough. Do you understand me? Murat?
Yes.
Yes, sir.
So honestly, I expect better presentations as the previous teams have done so far. Okay? So this presentation is not what I expect from you. It is below the, my expectation. Okay? So I hope that in the next presentation, explanatory data analysis, you will not show me this kind of web pages, but you would show what you have done on that information by using Orange tool. As an engineer, you need to get into the data, understand it, right? Comment on it, use the data to show me that you understand the problem. Otherwise, just the numbers provided by somebody else. For example, what you are gonna do with the sharp right turn? Because as far as I see that, it's very low in samples, right? Can you show the target value? The target value.
Yeah. So the reason the sharp right value is less frequent is obviously because it's...
What are you gonna do with that data set?
Yeah,
imbalanced data set.
We can use some resampling technique for this, for oversampling or undersampling for this.
So you yourself in your presentation must express these concern, and with some measures. You need to mention about some measures, what you plan to do. Because it's very obvious that it is imbalanced, right?
Yes.
The first and the second ones are turn left, turn right. I don't know. Slide right, the first two.
Yes.
So they are very frequent, right? And why we don't have sharp left turn? Why we don't have sharp left?
It's going in a clockwise manner.
Yes, it's a circumnavigating room, so it's for the most part going to be moving or turning in one direction. So it's for circumnavigation, specifically.
But then there must not be left turn. Okay.
Maybe the robot will turn to right, so it has to go left a little bit.
Right.
There can be concave and convex turns within the geometry of a room.
Might be. And do you think that the number of the samples are enough? The data size?
I think yes, but we have 5,000 samples for.
I think 5,000 is not enough. Huh? From 24 sensors, am I right? There are 24 sensors.
Yeah. 24 sensors.
So do you think that all of the sensors are important? Have you checked this?
We are using every sensor in this data set.
Yes, I see, but have you analyzed that with respect to turn right, for example? Every sensor is equally important. Do you believe that?
We did look at the data, and for example, we can see that the rear sensors don't receive a lot of,
so in your presentation, you had to express that, for example, the rear sensors is useless in that experiment. Am I right? Maybe you need to remove these sensors from the data set. But you don't have any analysis on that. and you didn't share any results of this kind of analysis. So do you understand why I am saying that your presentation is under my expectation?
So we hoped to answer those questions during the question and answer section. But yes, okay, we understand.
So in your presentation, in the initial data presentation, you need to provide such information so that we decide that throughout the 10 weeks, you will spend your time on that data set. If it's a mischoice, then you will lose your time. You couldn't get to anywhere. And you cannot change the data set afterwards. You have to stick to your data set. If your first step is incorrect, how can you finalize your project? So it is very important to begin with a good initial data set analysis. And in 2 weeks' time, you are going to present your explanatory data analysis, right? And in the explanatory data analysis, you would say that, sorry, sir, this is not a good data set. We cannot do this because blah, 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 blah. So to prevent this happening, we have this 20-minute session to discuss the data set, if you can use it or not, by just looking some fundamental issues in the data set with respect to your goal. Do you understand my point?
Yes.
sir.
Do you want to continue with this robot navigation data set?
I think we can continue.
Yeah, I guess.
Okay, then let's stop at this moment. But I strongly suggest to go over this presentation, and you already watched the other presentations. For the explanatory data analysis, you are gonna be the first team to present your explanatory data analysis, EDA. Please check all the EDA videos in my YouTube channel, and please read the documentation about how to prepare an explanatory data analysis on the Moodle. All right? Please well prepared for the next presentation. All right?
Okay.
Okay.
Yes, sir. Thank you.
Okay, Zeynep?
Okay, hocam.
All right. Any questions from the audience?
No, hocam.
Eray?
I don't have any questions.
Okay. Thank you for
No.
the question. Any question?
No questions hocam.
Okay.